So this is the robot arm FSM simulated. We can see in the lower left hand corner we have our reset and action buttons. They go through edge detection along with these two lines which simulate movement in the motor. Those also go through edge detection to get synchronized with our clock. Running at 1 tick frequencies, and you see the motor clock runs with a high and low duration at 200 ticks, so its frequency will be 1/200th of the actual synchronous clock. We're going to simulate at the highest possible frequency of 4.1 kilohertz. In reality, on the breadboard, we are running at 22.7K. Yeah, so these two inputs labeled partner 1 and 2, they simulate the other robot arms that we are working with for design day, controlling the two other motors. And those inputs should go high whenever they are ready for the next position. This area right here is the next state logic for our factored FSM with 3 states. The multiplexers implement the active high reset. This area over here is logic about incrementing the address counter. As I mentioned in the report, I have some concerns over this counter incrementing before write enable has time to, before the setup and latch time pass. This is the OR gate I'm talking about, where the count will propagate first through the OR gate, whereas the write enable only goes through one AND gate. You can see another shift register with edge detection here, and this is because I only want the address to increment once every time I reach equality and like switch into the idle state. All this logic up here simulates the actual motor. So this is the 12-bit counter that counts motor positions. When we start the simulation and reset, you'll see that we reset to the midpoint, which is 2048 or 800 in hexa. All this logic won't actually exist on the actual breadboard because this is again just to simulate the robot arm. And count up, count down again also simulate moving it clockwise, counterclockwise. The comparator block right here, and some output logic giving step and direction, which are feeding in back into our simulated robot arm. So let's go ahead and start the simulation. Ticks enabled. There we go. Okay. So you can see our shift register there. If I go ahead and hit reset, we are in state 0 and we are ready to record, and as you can see our counter is reloaded to midpoint. So let's simulate someone moving the robot arm up, which could be clockwise, counterclockwise. You can see the counter counting up. Okay, so let's say they stop moving it and decide they want to record the position, so they press action. You can see it's stored in the first address. Again, with my earlier concern, this OR gate in here is enough so that the propagation delay works out. That will write enable first and then increment the address. That remains to be seen what will happen on the actual breadboard. So let's go ahead and record 4 positions. You can actually record while we're still moving. 3. Then for this one, I'll just simulate counting down, or we move the robot arm in the other direction. Okay, so we have our 4 positions. As you can kind of tell, we are in state 2, the idle state. And the reason we are stuck in the idle state is because our partners say they are not ready. They are not in the idle state also. So as soon as we say both partners are in the idle state, we'll transition into state 1, the moving state. And as you can see, step is actually pulsing outputs and the counter is seeing that. The simulated robot arm is seeing that. We've stopped at 85, matches our address. We've changed to the next address. We are now back in the idle state. And again, if we say our partners are ready, we'll start pulsing out, and like you'll see the counter changing until we get to 8A. Then we're in the next state. And so I've just left the partner inputs on for now. And you can see that we're cycling through all our states. So our motor is actually moving to the states. We're counting down to this one, up to this one, up again, or actually down this time. And we just keep cycling, of course, until someone hits, oh, just to demonstrate, if I press action here, like, the machine works normally. There is some logic built in, such that it doesn't matter if someone spams action during the moving state. But if I press reset, as advertised, everything resets. We are back in the midpoint on the counter. We are ready to record 4 more states, or 4 more positions. We are in the recording state.